Alright, so today we're going to learn how to add and subtract rational expressions, and this is a very, very, very important topic. This is going to stay with us for the rest of the semester, and you'll also have to be able to add and subtract rational expressions into calculus, so this is very, very important. The steps that you are always going to go through when adding and subtracting a rational expression is, first of all, you're going to factor all the denominators and find the least common denominator. After that, you're going to go through the process of getting a common denominator, and I'll show you how to do that. And then add and subtract the numerators, then simplify and reduce. So these are your 4 steps you're going to go through every time. And I'm going to first just talk about how we just add fractions in general without any kind of variables or anything hard. We're just going to do something, we're just going to look at some really easy examples. So if I wanted to, let's look at a couple. If I wanted to add 2/7 and 3/7, I could add those because the denominators are the same. So since the denominators are the same on those 2 fractions, I can add the tops and make this 5/7. Now, the denominator, notice, denominator did not change. Okay, I didn't say 7 plus 7, I didn't say 7 times 7, I just left that denominator as 7, okay? Let's look at a different one. Let's look at a problem where the denominators are not the same. Let's look at 1/4 plus 1/2. Now, you could probably figure out that that's going to end up being 3/4 without doing this process, but I want to show you how you would get a common denominator by using this common denominator process with something easy first. So, the common denominator, the least common denominator that both 4 and 2 would divide into evenly, so a number that 4 and 2 would go into evenly is 4. So 4 is already a 4. It's good. This 1/2, though, the 2 is not a 4. So in order to make it a 4, I would have to multiply it by 2. And now, if I multiply the bottom by 2, I also have to multiply the top by 2. And the reason that this is okay to do is because when I multiply by 2/2, that's really like multiplying by 1, so it doesn't change this fraction. So watch what it does to the second fraction. I'm going to have 1/4 plus 1 times 2 is 2, 2 times 2 is 4, and I know that 2/4 really is just 1/2 if I reduce it. But by doing this, it allows me to get this common denominator. So this is going to end up being 3/4. And there again, the denominator did not change. So let's use this same method to add fractions that have variables in the bottom. So my least common denominator, I need one of each factor. So I need an x plus 2 and an x minus 3. So in this problem, I'm going to make it a little bigger. In this problem, my first fraction in the bottom, these are factors, so I'm going to go ahead and group them just to make it look better. But the first fraction needs an x minus 3. And so I'm going to put an x minus 3 in the top and the bottom. The second fraction needs an x plus 2. And so now the denominators are the same. They're in different orders, but that's still the same thing. Okay, I can multiply in any order. And so I'm going to go ahead and my steps over here, we didn't have to factor the common denominator, but we got a common denominator. Now I need to add and subtract the numerators. So to do that, I'm going to have to go ahead and distribute the 4 and the 7. So this is going to give me 4x minus 12 plus 7x plus 14. All over, I'm only going to write my common denominator one time. Okay, just like we did with these numbers, I only wrote the common denominator one time. So same thing here. And then I'm just going to simplify and reduce if I can. So I'm going to go ahead and combine my x's. So 4x plus 7x is going to give me 11x. And then negative 12 plus 14 is going to give me a plus 2. And then that's going to be over my common denominator. And so then I cannot factor anything out of this top part. I can't cancel anything at this point. These 2's will not cancel. They are attached to a plus, and so we cannot cancel those. So this is the simplest I can get that expression, and so there's going to be my final answer. Alright, let's look at one where we have to actually factor the bottoms to find the least common denominator. So I'm going to go ahead and factor both of these backwards FOIL. So this is going to be x and x, 2 and 1, plus and plus. Over here, I'm going to have x and x. It's going to end up being 2 and 3 plus plus. So now, the three different factors, the least common denominator, the three different factors that each of those fractions needs, they each need an x plus 1, they each need an x plus 2, and they each need an x plus 3. So this first fraction already has an x plus 1 and an x plus 2. It needs an x plus 3 to have all three factors. Now I'm going to go ahead and group that. This one needs an x plus 1, so I'm going to add an x plus 1 to the top and bottom. And so then if I go ahead and distribute across the top, that's going to be x squared plus 3x from the first fraction. And now these two terms, I'm going to come over here to the side and make this my little scratch work piece. And I'm going to FOIL these out because I need to multiply them, so I'm going to need to FOIL. And so when I FOIL these, this is a real easy case because when I multiply the first two, x squared, x times x is x squared, the outside terms give me a plus 1x, the inside terms give me a minus 1x, and then the last terms give me negative 1 times 1 is just a negative 1. And so you can see that these two terms are going to cancel out, and so I'm just going to get x squared minus 1. And that should make sense because if I were to factor x squared minus 1, this is what I call dots, a difference of two squares. So it would factor into this. Okay, so when I FOIL it out, it's just going to be this. So I'm going to go over here and write plus x squared minus 1. And then I know that all of that is over x plus 1, x plus 2, x plus 3. And so then I'm just going to combine like terms. So I'm going to combine my x squareds. So that's going to give me 2x squared plus 3x minus 1 over x plus 1, x plus 2, x plus 3. Now, I would try to factor this if at all possible. So I'm going to look at just attempting to backwards FOIL it. Okay, because I would want to backwards FOIL this to see if it would cancel out some of these factors in the bottom. So if I were to try 2x and x, 1 and 1, the outsides give me 2x, the insides give me 1x, and I could combine those to get 3x, but my signs would have to be plus and plus. And if they were plus and plus, I would never be able to get this negative 1 right here. So this is not going to factor. So if it's not going to factor, then my final answer is going to be this. But we always need to try to see if this will factor and cancel. Okay, it won't, so this is my final answer. Alright, I would try this one on your own. I'm going to go ahead and work it. But I would pause and try it on your own if you want to. First thing I'm going to do is go ahead and backwards FOIL. And so when I backwards FOIL, this is going to be x plus 3 and x minus 2. This is going to be x plus 3 and x plus 1. So I'm going to make my little scratch work over here. The three factors that I need is going to be an x plus 1, an x minus 2, and an x plus 3. So in my first fraction, I'm going to go ahead and group these two things. In my first fraction, I need to put an x plus 1 in the top and the bottom. So I'm going to go ahead and add my x plus 1. This needs to have an x minus 2. Now, I've got two things in the numerators that I'm going to have to FOIL. I know it's all going to go over that LCD, so I'm just going to go ahead and write that in the bottom. And do my scratch work over here for the top in my little bubble. So I already know we just FOILed this out, so that's easy. I'm going to go ahead and just say that's going to be x squared minus 1. Now, when it comes to both of our problems before have been plus. Okay, so we didn't really have to worry about that plus, but now I've got a minus, and so when I have a minus, what I like to do is go ahead and say this is going to be plus and then a negative, because I have to distribute this negative, and if you don't distribute the negative, you will get it wrong every time. So you need to make sure that if it helps you to do plus and negative here, to remember to distribute it, or if you can just remember to distribute it without putting that plus there, that's fine too. But either way, you need to distribute this negative. And so the way that I'm going to do that is I'm going to go ahead and FOIL this out. So I'm going to go ahead and FOIL out x minus 2 and x minus 2. The first terms are going to give me x squared. Outside terms give me negative 2x. Inside terms give me negative 2x. Last terms would give me plus 4. And I'm going to go ahead and combine those middle terms to get x squared minus 4x plus 4. Now is when I have to remember that negative there, and I have to distribute that through that entire fraction. So let's go ahead and write what we have for the first fraction. So I've got x squared minus 1 from here. And then for the next side, I'm going to go ahead and distribute this negative. So this is going to be minus x squared plus 4x minus 4. And so then I can go ahead and do what we did on our last problems now and combine like terms. So I'm going to combine these like terms. The x squareds are going to cancel out, x squared minus x squared. And so that's just going to leave me with 4x. When I combine negative 1 and negative 4, that'll give me a negative 5. And so then I've got over x plus 1, x minus 2, x plus 3. And that would be my final answer because I can't factor this, okay, or cancel anything out. All right, let's look at 3 harder ones. So those were simpler ones. Let's look at some harder ones. Now, here, I'm going to have to go ahead and factor this third fraction into x minus 1 and x plus 1. So my LCD, I'm going to make my bubble, my LCD is going to be, I need to make sure that I have this x as a factor, okay? I can't just, when I'm getting a common denominator, if I were looking at these two, in order to get a common denominator, I could never just say minus 1 and minus 1 and say that's x minus 1 and that's x minus 1, and so I'm just going to minus 1 from the top and the bottom. You cannot do that. This is its own individual factor. This is its own individual factor, and x plus 1 is its own individual factor. So my least common denominator is going to be made up of x, x minus 1, and x plus 1. And so then my first fraction is going to need an x and an x plus 1. So I'm going to go ahead and add that. My second fraction is going to need an x minus 1, x plus 1. And then my last fraction is going to need an x, and so I'm going to add that x there. And so then let's go ahead and distribute where we can across the top. The first fraction is easy to distribute. I'm going to go ahead and say 3x squared plus 3x. Now my second fraction, I'm going to say plus a negative 2, so I make sure I distribute a negative 2. And let's go ahead and come out here and multiply all of that. I'm going to FOIL this first, so I'm going to leave the negative 2 out there. X times x is x squared. My inside terms, we FOILed this a second ago. This will cancel outside, inside. And then my last is just going to be minus 1. And so when I distribute that, that's going to give me a negative 2x squared plus 2. And then for my last fraction, that's a plus, so I don't have to worry about it. And I'm going to distribute that x to there. So that's going to be plus x squared plus 3x. And it's all over my common denominator. Now, let's combine like terms. So I'm going to say 3x squared minus 2x squared is 1x squared. And 1x squared plus another x squared is just going to be 2x squared. Now, my 3x and 3x will combine to give me a 6x. And then I've got a plus 2 left over. And so then that's over my common denominator. And then the only thing that I could possibly do is factor a 2 out of the top. So I'm going to do that. And then if you look at that top quadratic, the x squared plus 3x plus 1, you'll see that this is not going to be able to factor anymore. And so this is going to be my final answer. And so that's all I can do there. Alright, number 11. This is one on the group 5 sheet that I'm going to give you for homework. And so you don't have to redo this one, but it's a good example. I want to show you how to do it. So let's go ahead and figure out what our LCD is. So least common denominator, I need an x, x plus 1, x minus 1. So same as the last one. And so for my first fraction, I'm going to hide that 11, make this just a touch bigger. So for my first fraction, it needs an x plus 1, x minus 1. X plus 1, x minus 1. My second fraction needs an x and an x minus 1. So it needs an x and an x minus 1. And then my last fraction needs an x and an x plus 1. Okay, so each one have all three factors now. So across the top, we foiled this a whole lot today, so I'm going to go ahead and foil it again. I know it's going to foil into x squared minus 1. There are no minuses in this problem, and so I don't have to worry about distributing a negative. So I'm going to go ahead and just distribute that x, so that's going to be plus x squared minus x. Then my last fraction is going to be plus x squared, and then plus x. And I know that's all over common denominator, which is x times x plus 1, x minus 1. And I haven't said this before, but you always want to leave this factored out in case something in the top will end up canceling one of those factors out. So you always want to leave that factored out. And so then I'm going to go ahead and combine my like terms. So this is going to give me 1x squared, 2x squared, 3x squared. So 3x squared minus x and plus x are going to cancel each other out. And then I'm going to have minus 1 there. And so then that's over x times x plus 1, x minus 1. And I cannot factor this any further. Okay, this is not a difference of two squares. 3 is not a perfect square. So this is going to be my final answer. Alright, now we have one more example, and this is number 13 on your group 5 problems. And this one, I'm going to show you a method of how to do this one that will make this one a little bit easier. And so I'm going to go ahead and factor this right here, because I know that's going to backwards FOIL into x plus 2 and x minus 2. Now, it would be really nice if these two factors were in this order, okay? So I'm going to go ahead and put them in that order. And to do that with the first one, 2 plus x is the same as x plus 2, so that's no problem. I'm just going to rewrite it. Now, the other problem over there, I'm going to draw my bubble down here this time. I'm going to have to take that 2 minus x, and if I want the x in front, I'm going to have to rewrite it. Whatever sign is in front of the term, though, I've got to keep it with that term. So this is a negative x, and then that's a positive 2, so I'm going to write plus 2. Now, I don't have a negative x plus 2, so what I'm going to do is factor this negative out. And so when I factor that negative out, that's going to leave me with x minus 2. And so then that looks like that x minus 2 looks like one of the factors that I have already. And so then what I'm going to do is make this negative and then x minus 2. Now, if I have a negative on the bottom, let's just look at an easy example. So if I have a 5 divided by negative 1, all a negative 1 in the bottom does is just basically makes the top negative. That would just be a negative 5. So the same thing is going to happen right here. This negative can just come up and make this negative a plus. And so I'm going to bring that up and do that. So I'm going to erase this. I'm going to erase that negative, and I'm going to bring it up and just make that a plus. And so now I don't have to worry about distributing a negative here. I just have to worry about it here. And so the reason that I do this whole process is because it makes it easier to find what the least common denominator should be. Now I can really easily see that the LCD should just be x plus 2 and x minus 2. And that's really easy for me to see. So I'm going to go ahead and in this first fraction, I'm going to add an x minus 2. Now you may be wondering, why didn't I turn these around? Well, because I'm going to have to end up foiling these out anyway. And so for me to turn this around and factor out a negative is really going to be more work than I need to do. The only reason I did it down here is so these factors, these right here, would look like these factors, and I could find an easier least common denominator. Now my second fraction is going to need an x plus 2. And then my third fraction doesn't need anything. So I'm going to go ahead and FOIL across the top here and here. And so then 1 times x is x. first. The outside, 1 times negative 2 gives me a negative 2. Insides are going to give me a negative x squared. And then last, that's going to give me a positive 2x. So that's for my first fraction. Then, plus. Second fraction, I'm going to write in blue. And so then 1 times x is x. 1 times 2 is a positive 2. X times x is just a plus x squared. And then x times 2 is going to be 2x. And so I just FOILed out that second fraction. And then I'm not going to write a plus there. I'm going to change colored pencils again, or pens. And so then I'm just going to have, I didn't need to add anything to that third fraction, so I'm just going to write minus 3x. And so then here is everything in the top, and that's a lot. But I know that it all is going to go over that common denominator, so I'm going to write that common denominator as x plus 2, x minus 2. Alright, so now I'm going to combine like terms. And so I'm going to look at the x squareds first. Negative x squared, positive x squared is going to cancel. And so then I'm going to go ahead and just add my x's up as I go across. So x plus 2x is 3x. Plus another x is 4x. Plus 2 more x's is 6x. Then I've got minus 3x. So 6x minus 3x is just 3x. And then I've got a negative 2 plus 2 that cancels out, and that's everything. So I end up, all of that is just going to simplify to 3x. And so I end up with 3x over x plus 2, x minus 2. And this would be my final answer. And so then that is how we are going to go about subtracting, adding and subtracting rational expressions. There are also going to be some extra credit problems that are on that Group 5 sheet, and I'm going to make a video specifically on how to do one of those extra credit questions. And let's actually, I'm going to give you some that are going to look like these problems. So let's go ahead and do this. So 65 on another page that I'm going to have you do for some problems on. Those problems look like this. They give you these problems. And so these are problems that are going to end up being complex fractions. So I may just wait and do those in the complex fractions video. That one's going to be a complex fraction, so we're not going to do that. We'll come back to it. But there's 163 will look like rational expressions, like what we just did. So if you have a problem like this, and you have negative exponents, the way you get rid of negative exponents is you drop it to the bottom of whatever it's being multiplied by. And so what I'm going to do to get rid of this term that has a negative exponent is drop it to the bottom of the x squared that it's being multiplied by. So this is going to be x squared over x squared plus 1 to the 5th. And then I'm going to minus, this is like a 1 that's being multiplied by since there's nothing in front of that. And so then I'm going to drop it to the bottom. It's being multiplied by the 1. So I'm going to drop this to the bottom of the 1. And so that's what I've got. And so then this is like a problem that we just did. And so our least common denominator would be an x squared plus 1 to the 5th. And so in order to make this x squared plus 1 to the 5th, I would need to add an x squared plus 1, or multiply the top and the bottom by an x squared plus 1. And so then that's what I'm going to do. So across the top, this is going to be x squared. I'm going to plus a negative, so I remember to distribute the negative. So that's going to be minus x squared minus 1 over x squared plus 1 to the 5th now. My x squared terms cancel out, and so my final answer is just going to be negative 1 over x squared plus 1 to the 5th. So if you ever see a problem with negative exponents, this is how you'll do it. You'll just drop them to the bottom of whatever they're being multiplied by, and then find your common denominator like we just did.